Welcome to Richgro Garden Products. My name is Jeff Richards. Richgro is a multifaceted garden product company producing for both the home gardener and for the professional growers. We're going to show you around the facility and how it works. My grandfather started Richgro in 1916. He was followed by my father, who got into stock food manufacturing, and I learnt from him the principles of animal nutrition and converted it to plant nutrition and started to produce fertilisers and then composts. The other main element as we have grown as a company was our need for electricity in the production of products, which led us to build our own bioenergy plant. The process of anaerobic digestion is basically in three stages. The first stage is the receival of the waste food product. The next stage is hydrolysis, which is the stabilisation and the initial fermentation of the product. The next stage is where it's put into the main digesters and the materials are exposed to a whole range of bacteria that have been established. After the food waste broken down a lot, it goes into an outfill tank as digestate, ready to be delivered to either farms or our composting plant up at North Bannister. Let me go into the first stage in a little bit more detail. We get a many and varied diet, if you like, of materials coming in, or we receive constantly product from the breweries, from the milk factories. Bakeries also have a fair amount of residue. Fruit juice people, cool drinks. We receive from outlets like the metropolitan fruit and veggie markets, Coles and Woolworths and Hungry Jack's. We receive their product. Anything that has sugars and fats, carbohydrates, are excellent feed for the bacteria that break it down. So it can take a really broad range of products in. We clean it up by removing any plastic packaging whatsoever. Paper packaging, cardboard can go in with the material and break down, but we certainly can't afford to have plastic in the system, or glass. They're the two contaminants we really don't need. It is all produced into a soup-like product that's fed into the system. From there, the materials are pumped to a second tank, which is called a hydrolysis tank, where the initial fermentation starts to take place. But there's no added bacteria at this stage. It's the normal hydrolysis process. It is operating with a pH of about 3.5, so it's quite acidic, which you'd understand with a lot of cool drink and beer in there. It becomes quite acidic. The next stage is it's fed into, from the hydrolysis tank into the digesters themselves. These two tanks are 2.5 million litres each, and they're fed on an hourly basis with about 2 tonne of material. In the digesters, it's full of all the bacteria that are required to break down that food stuff. The methanogens, which are one of the bacteria, they produce the methane gas, which is about 2/3 of the gas that's produced, the remainder being CO2. These gases are what we're really wanting to harvest from those tanks, and they are fed to our generators via a chilling plant to make sure all the moisture or water vapour that is in those gases is removed. So when you look at our plant, it's got the two big digesters with the white domes on top, which are blown up with air to keep the domes tight, but within it there's a bladder that the two gases go into before we draw them off. Within the digesters, our pumping system acts as our stirring system. The liquids are injected at an angle so the contents of the tank is circulating, and to get the material actually turning from top to bottom, we draw down some of the methane gas, or the two gases, down to the base of the unit, and they're injected. And like when you go swimming, the bubbles start small, and as you get higher up in the tank, they're quite big. And this ensures the tank is being circulated both horizontally as well as on a vertical plane. So you get a lot more efficient activity within the tanks with that happening. The other thing, all the pumps are what we call chopper pumps. So you're downsizing the food waste, getting finer and finer as you go, because the greater the surface area, the more the bacteria can attack the food waste. The tanks are dark blue in colour to ensure that we absorb the heat from the sun rather than repel it, because you want to keep the temperature in the tanks to 70 degrees, approximately the same as a human stomach, because that's the ideal temperature that the bacteria thrive in. Our anaerobic digestion process enables us to produce about 2.4 megawatt of power. We are now totally self-sufficient for power and off-grid, and increasingly with the use of the liquid in our production of compost, we have a big advantage because of our level of sustainability. So it has meant a big difference to the way we operate and our level of efficiency. The final stage of the AD process is when the digestate is fed out of the final tank into the bulk trucks for the removal of the digestate. Within the tanks, the digesters themselves, the pH of around 3.5 is changed quite dramatically to in excess of 7. Perfectly okay to be either sprayed onto a crop as a liquid fertiliser as it's drawn off. It's easy to draw off the material that has given off all the gas, because once it stops giving off gas, it settles to the bottom of the tank and we draw it off the bottom of the tank. But that material, which we call digestate, is invaluable for not only the use on for farmers, but in making our compost, because it provides all the nutrients, all the trace elements are in that material that it's picked up through, whether it's been a lettuce growing and it's been fertilised and it's picked up the trace elements to get maximum growth. They all end up in that liquid, so it's a very valuable organic source. So we get 120 tonne a day of that material. Some of it goes direct to farm for application to pasture crops or even crops that are in early stages of growth. The balance ends up at our composting plant up at North Bannister, where it is used to provide the liquid to enable the composting. Because to compost properly, you've got to have about 50 to 55% moisture. So all the moisture we collect is invaluable, and especially if it's high in nutrients. The benefits of using anaerobic digestion are manyfold, but the main one is, of course, we're in a totally enclosed environment. We can take the most vile waste from food you can get and process it without any odour escaping. So that is a big one. The second reason is that we can retain all the nutrients that are naturally in food, and we can use those to grow the next crop of food. So it's totally ongoing, the process. Richgro have always had an interest in the environment, and we've moved increasingly from using artificial nutrition to organic wherever we can, and it's the same with chemicals. Wherever we can find an organic alternative, we'd far rather offer that than an artificial one. If the food waste we receive was going to a tip, it would end up as landfill gas. The methane would be going up into the atmosphere. As a result of our AD plant, we can quantify that methane because we're generating it, so it can be measured, and it enables us to qualify for carbon credits. Here at Richgro, we turn waste into energy. A lot of our products, in fact, we've calculated about 85% derived from other people's waste. It's our great way of helping the circular economy, and with the emphasis at the moment on climate change, which is real, we need to ensure that we as a company continue down that pathway of maximising our organic streams and producing a clean environment as much as possible.